6.1 rate of reaction. So a rate of reaction means how fast the reaction is happening. So the rate of reaction you can measure as change in concentration in a given time. How fast the concentration is changing. So let's just look at that. So R rate is equal to delta C, change in concentration over the time that this change is happening. What is the overall rate of production nitrogen dioxide in the system? So nitrogen, oxygen react, give you NO2. If the concentration of nitrogen dioxide changes from 0.32 to 0.8 mole per liter in 3 minutes. Okay, so the final concentration need to be minus the initial concentration divided by the time. So final concentration minus initial concentration is going to be concentration as mole per liter. And then the time is 3 minutes. When you're writing the R, you need to put the units correctly. Another example, what is the average rate of production of ammonium in the system between 1 and 4 minutes if the concentration is changing from 3.5 after 1 minute and 6.2 after 4 minutes? So final concentration minus initial concentration divided by final time minus initial time. Delta T is final time minus initial time, 4 minus 1. Changing concentration is final concentration minus initial concentration, which give you 2.7. So changing concentration 2.7 divided by the time will give you the rate of change. You can practice 1 and 2. This page is 361. Look at this. This is plotted concentration of that reactant as a function of time. My reactant is CH4 and Cl2. That's why it is the slope of that is negative, right? Because its concentration will become smaller and smaller because it's progressing. Is as the times goes, these two react and will turn into the new element, right? Means the concentration of these two will decrease over the time. So between two time, if you draw a line, it will give you a secant line. The slope of this secant line give you the rate of the reaction, average rate of the reaction. Average rate of the reaction is how fast the reaction happening between the two time. As you see, this is the slope is rise over run. Rise is changing concentration, and run is time, which means the slope is the rate of reaction. Here, as you see the tangent line at each point, slope of the tangent line at each point give you the rate of reaction at that time. Same thing, the slope of this line, tangent line, give you the rate of reaction at point B. As you see, the slope here is much more sharper than the slope here. Means this is much more faster happening than this. At the beginning, the reaction is very fast, and when the concentration getting smaller, the rate of reaction getting smaller. So for the reactant, the change in rate is going to be negative. But the rate of reaction will be negative. For the product, on the other hand, the rate of reaction will be positive because the product will increase in constant increase, right? Note that the negative sign indicates a rate of consumption of the reactant. Positive is sign the rate of production of the product. Okay, look at this example. Consider the reaction of iodide, and hydrogen ion to yield iodine and water. But this is the reaction we have. What are the rate of reaction with respect to various reactants and products? the rate reaction with respect to iodate ion, which is this one, is given to you. So the rate of reaction, if this is 1, this is 5, means this consume 5 times bigger. So if the rate of reaction of the IO3 is given, so for I, it would be 5 times bigger than that. Just multiply this one by 5, as you see here. Also, the rate of reaction here is negative, so for this one, going to be negative as well. Same thing, hydrogen going to be 6 times bigger than that, as you see. For the hydrogen, we do 6 times bigger than this. And for this one, for I2, is 3 times bigger than that. It's 3 multiplied by the rate of the reaction. And for H2O, it's going to be 3 times bigger than that also. It's 3 multiplied by that also is 9, 10 power negative 5. Now, when nitrogen and hydrogen gases react to produce ammonium gas, the reaction is given. What is the rate of combustion of each of the reactants when the rate of production of ammonia is 4 and power negative 3? So here is 4 for this one, for NH3. NH3. The rate of reaction is 4, 10 power negative 3. I want to find the rate of reaction for N2. So the ratio is for 2 mole of NH3. You have 1 mole of N2. That's why the NH3 and NH3 cancel. And if you divide this one by 2, will give you the rate of reaction of N2, as you see. 4 divided by 2 is 2. The same thing for H2, NH3 is 4, 10 power negative 3. The ratio is 3 of H2 is 2 mole of NH3. This 2 can 4 multiplied by 3 divided by 2 will be the answer is 6, 10 power negative 3. So for the practice, you can do question 4, 3, and 6. Measuring reaction rate. So we have a specific device for different reactions. We can use different device to measure the rate of reaction. Some of the reaction that the gases produce, you can have a device that measuring the volume and the pressure. So the greater change in volume and pressure in the same time interval will tell you the faster rate of the reaction. For the reactions that involve ions, we have a device that can measure the conductivity. More the conductivity is higher, means the reaction is producing more ions, it's faster. Reaction that change color, you can use the spectrometer to see how fast the color changing is happening.